Have you ever looked up at the night sky and wondered if we are alone in the universe? This question has stirred human curiosity for centuries, leading to the birth of a fascinating field of study known as astrobiology. Astrobiology, at its core, is the study of life in the universe. It's a quest to understand if we are alone in this vast cosmos, or if life has found a way to thrive beyond our pale blue dot. It's a blend of curiosity, science, and the innate human desire to explore the unknown. Astrobiology is an interdisciplinary science, a perfect blend of multiple fields of study. It's like a grand cosmic detective story that brings together astronomers who gaze at the stars and planets, biologists who study the intricate mechanisms of life, and geologists who understand the dynamic processes shaping planets. Together, these scientists embark on a journey to unravel the mysteries of life beyond Earth. At the heart of astrobiology lie three fundamental questions that have intrigued humanity since the dawn of civilization. First, where do we come from? This question delves into the origins of life on Earth, seeking to understand how life began in the first place. Second, are we alone? This is the quest to find life elsewhere in the universe, to see if Earth is a unique haven for life or if life is a common phenomenon across the cosmos. And finally, where are we going? This question probes into the future of life, both on Earth and beyond, contemplating the potential for humans to become an interstellar species. Each of these questions represents a unique aspect of astrobiology, and together, they form a comprehensive framework for exploring the concept of life in the universe. Astrobiology is more than just a scientific discipline. It's a journey into the unknown, a quest filled with wonder and mystery. It's a testament to our human spirit, our relentless pursuit of knowledge, and our desire to find our place in the cosmos. Astrobiology is our key to unlocking the answers to these profound questions. Life as we know it requires certain conditions to flourish. But what about life as we don't know it? Let's delve into the essential ingredients for life on Earth: water, energy, and organic materials. Water is the universal solvent, the medium where biochemical reactions occur. It allows nutrients to be carried to cells, waste products to be carried away, and proteins to be structured. Without it, life as we comprehend it simply would not exist. Next, energy. Life is a complex dance of molecules and reactions, and this dance requires fuel. On Earth, life's energy primarily comes from the sun, either directly through photosynthesis or indirectly through the food chain. But energy can also come from chemical reactions like those that occur around deep-sea vents. Now, organic materials. These are the building blocks of life: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, often abbreviated as CHNOPS. They form the DNA, proteins, and fats that make up living organisms. But what if we told you that life isn't always so picky? Enter extremophiles, hardy organisms that thrive in extreme conditions. Some love the scorching heat of hot springs, others the crushing pressure of deep-sea trenches. Some can survive in extremely acidic or alkaline environments, while others can tolerate high levels of radiation. There are even psychrophiles that can live in the coldest places on Earth. These extremophiles break all the rules we thought applied to life, expanding the potential habitats where we might find life beyond Earth. They show us that life is incredibly adaptable, that it finds a way even in the most inhospitable environments. So, as we gaze into the vast expanse of the universe, we must remember that life might not look like what we expect. It might not need a balmy, Earth-like planet. It might be hiding in the acidic clouds of Venus, beneath the icy crust of Jupiter's moon Europa, or in the methane lakes of Saturn's moon Titan. If life can thrive in the harshest conditions on Earth, imagine what could be out there in the cosmos. So, how do we go about finding this elusive extraterrestrial life? Well, the search for life beyond Earth is a multifaceted endeavor, employing a variety of innovative methods. One approach is to study microbial life on Mars. Scientists analyze soil and rock samples from the red planet, looking for signs of past or present microbial life. They hope to find microfossils, tiny imprints, or shapes in rock that could indicate the presence of ancient microbes. But our search isn't limited to our neighboring planets. We also venture into the far reaches of space, analyzing the atmospheres of distant exoplanets. With the help of powerful telescopes, scientists can observe the light that passes through an exoplanet's atmosphere. Different chemicals in the atmosphere absorb different wavelengths of light, creating a unique spectral fingerprint. By studying these fingerprints, scientists can infer the composition of the planet's atmosphere and, potentially, the presence of life. This brings us to the concept of biosignatures. A biosignature is any substance or phenomenon that provides scientific evidence of past or present life. They can be chemical, such as the presence of oxygen or methane in an exoplanet's atmosphere, or physical, like the aforementioned microfossils. Biosignatures are exciting because they don't just tell us that life exists, they can also give us clues about what that life might be like. For example, the presence of oxygen could suggest photosynthesizing organisms, while methane might indicate life forms similar to Earth's methanogens, microorganisms that produce methane as a metabolic byproduct. However, it's important to note that finding a potential biosignature isn't definitive proof of life. It's more like a tantalizing hint, a sign that warrants further investigation. Scientists must carefully rule out non-biological explanations for the phenomena they observe. The search for life beyond Earth is like a cosmic detective story, with scientists piecing together clues from across the universe. The quest is far from over, but every discovery brings us one step closer to answering one of humanity's most profound questions. Are we alone in the universe? In the quest for life beyond Earth, every new discovery is a thrilling step forward. The field of astrobiology has been abuzz with fascinating revelations. One of the most significant has been the discovery of water on Mars. In 2015, NASA's Mars Reconnaissance Orbiter provided strong evidence of liquid water flowing intermittently on the Martian surface. This discovery not only bolsters the possibility of life on Mars, but also hints at the potential for human habitation in the future. Meanwhile, our exploration of the cosmos has led to the detection of potentially habitable exoplanets. These are planets beyond our solar system that could have conditions suitable for life. The Kepler Space Telescope, before its retirement, had identified over 2,000 such exoplanets. Some of these, like Kepler 186f, are similar in size to Earth and orbit within their star's habitable zone, where conditions might be just right for liquid water to exist. But our search for life beyond Earth doesn't stop at discoveries. It's also propelled by groundbreaking missions. The Mars rover missions, for instance, have been pivotal in our understanding of the Red Planet. The Perseverance rover, which landed in 2021, has the explicit goal of searching for signs of ancient microbial life, furthering our quest to understand whether life ever existed on Mars. Upcoming missions are equally promising. The launch of the James Webb Space Telescope, set to be the premier observatory of the next decade, will revolutionize our understanding of the universe. It's designed to look back over 13 billion years to see the first galaxies that formed after the Big Bang. But importantly for astrobiology, it will also study exoplanets and their atmospheres, searching for the chemical signatures of potential life. Every new discovery and mission brings us one step closer to answering the question, are we alone? Imagine the day when we finally discover life beyond Earth. How would that change our understanding of the universe and our place in it? Discovering extraterrestrial life would be a monumental moment in human history, with profound philosophical implications. It would challenge our understanding of life's rarity and value. Are we unique, a cosmic accident, or is life a common outcome in the universe, emerging wherever conditions allow? Finding life beyond Earth, even in its simplest form, would tip the scale towards the latter, suggesting that we are not alone, and life as a phenomenon might be far more common than we ever imagined. Such a discovery would also have a profound impact on society. Cultural narratives would be rewritten as humanity grapples with the reality of not being the sole bearers of life in the vast cosmos. Religious beliefs, many of which are centered on human uniqueness, might be challenged and reevaluated in light of the new evidence. Ethically, we would have to consider our responsibilities towards these newfound life forms. If we find intelligent life, how should we interact? What rights would they have? And if life is found in its primitive forms, do we have the right to interfere or even terraform their habitats for our own use? These are complex questions that we would need to address, forcing us to redefine our ethical boundaries. Moreover, the discovery of extraterrestrial life could lead to advancements in science and technology, driven by a renewed enthusiasm for space exploration. It might even unite humanity, reminding us of our shared heritage and the collective curiosity that defines us as a species. The discovery of life beyond Earth could fundamentally change how we see ourselves and our place in the cosmos. Until then, the search continues.